So what we're building towards right now in this course is ways to find zeros of polynomial functions. And we're going to start with a function that you're already pretty familiar with, which is quadratic functions. We're going to go quick. This is more of a review of what we learned in Algebra 2. So there's a bunch of different reasons why we might want to study the zeros of a quadratic function, aka where it touches the x-axis. And this example of your friend shooting an air ball is as good of a reason as any. So we're going to study several different methods here. The first is by factoring. And hopefully we're already pretty good at this. Now the first step is going to be the same for all of these actually, is we're going to set our function equal to 0. So we're going to be like h of t at the ground, h of t has to be 0, so we're going to plug in 0 for y. I am going to ask you to show your work on this particular mastery, so it's important that you start with that step to show a good setup. And then I want to solve by factoring, which means I'm eventually going to rewrite my function as two binomials. First, though, I'm going to divide out this -2, so I'm dividing each piece by -2, each term by -2 rather, because I see that -2 divides all three of these. And that flips my signs, and then I'm going to bring that -2 down. And then I know each of my binomials is going to start with a t to give me a t squared. And remember, what I want these to do is to multiply to -5 and add to -4. And those two numbers, of course, would be a -5 and a +1. And I would just make sure I annotate here, add and multiply for those two pieces. Okay, so now that we have rewritten this equation by factoring, we're going to use what's called the zero products property, which says that if two, I don't want to say things, two quantities, we'll say, two quantities multiply to 0, at least one quantity must be 0. So that's really why this works. So I have two factors here. At least one of them has to be 0, right? And this, of course, gives 5 seconds. And this gives -1, and we are going to disregard our negative time. Right? So what we just found, of course, is the x-intercept of the graph right here. Okay, so that is factoring. You've already noticed we're going to use this a ton in this course, so it's important that you get a lot of practice on this and get really, really good at it. My next method is quadratic formula. So what this is somebody essentially realized that there was a pattern in the solutions to quadratic equations and derive this formula to describe them. So this is sometimes the long way. It will be the long way here, but it is sometimes the short way. So I'm going to set my equation equal to 0 always. And then I'm going to find my a, b, and c. Notice I have ax squared plus bx plus c. So a is -2, b is 8, and c is 10. And then I'm just going to plug it in. So I'm going to say x equal to -b plus or minus square root of b squared minus 4 times -2 times a times c all over. And then I'm just going to start to work it. I need to do the inside first. So I'm going to get -8 plus or minus 12 over -4. And then that actually gives me two solutions. It gives me -8 plus 12 over -4, which gives me my -1. And it also gives me my minus solution, which will be here, -8 minus 12 over -4, which will give me 5. Now, notice I can just type this into my calculator exactly as it appears. So I'm going to use the fraction button, that's alpha y equals, numerator over denominator, and this is going to make my life a whole lot easier. So I can just type it in. I have to just do one at a time. There's no plus or minus button, but I can just type it in exactly how I see it, and it'll spit out my solution, and then I can go back and edit and put the minus in there, and then it'll spit out my other solution. So that's a shortcut you can use. Make sure you type this in carefully, obviously. Now next here is my Space Jam problem, and the reason I call it that, right, is if we look at the graph, well, he shoots the ball and then it goes down and then it goes up. It's as if we've turned off gravity or something, right? So something weird is happening in this particular basketball game. What our goal here is to plug it into quadratic formula and see what happens, right? So I'm going to set it equal to 0 and then grab my A, B, and C. By the way, the reason that the graph changed is because I flipped the signs, right, on some of my coefficients here. So my A is now a positive 2, my B is now a negative 8, and I think my C I left the same. So I'm going to plug it in, and then I'll start to simplify it. We'll also try this one on our calculator. So negative 8 gives me a positive, plus or minus the square root. So notice I get a negative on the inside of my root. And when I type this into my calculator, so notice I've changed my signs now to match our problem. My calculator says non-real answer. That word non-real should sound familiar because we're going to use an imaginary number to represent this solution. So the answer here, to our question, is really no real solution. The ball never hits the ground, right? And we can see that from the graph. However, the solution to our equation, the square root of 16 is 4. We're going to write this as 8 plus or minus 4i over 4. And notice these are both divisible by 4, so I'll be like 2 plus or minus I. So I divided the 4 out of both terms. So that's a case that we can run into, and it happens right when we get a negative inside that root. The last problem we're going to consider here is a slightly different problem. And notice it's another like object hitting the ground question. So we know we're going to find a 0, but notice it says to the nearest hundredth of a second. So that tells me that I'm going to get some ugly decimal here. It's like that's what the problem writers are expecting me to get. So I'm going to actually use my graphing calculator to solve this one. So I'm going to hit y equals, and I'm going to graph my function. And then I'm going to hit graph, and it's going to draw me something. Yours may not look like mine. In fact, I'm zoomed out a little bit. You can zoom in and zoom out to see more of the graph. That's sometimes helpful. Now I've kind of zoomed out too much, right? I can't really see what I'm looking at. So I'm going to hit zoom, and then 6, zoom standard, is like a reset button. Okay, so now I can see a good piece of the graph. I can't see the top, but that's okay because I'm looking for that 0 point. And I can like move my cursor over there to find it, but that's like not super precise, right? And we want to the nearest hundredth of a second, and that's pretty precise. So I'm going to actually tell my calculator to find that for me. I'm going to hit second, calc, 0, and then left bound and right bound. This is a little bit tricky, so I need to pick a value that's like pretty close to each of these, but on the either side, right? So there's my cursor. It says left bound though, so I want to be to the left, right? So I'm going to move it up, and I can't see it anymore, but I know that I'm to the left of that 0 because my y is positive. So I'm going to hit enter, and notice I got a little arrow there right by the 0. And now right bound, I'm going to click down here to where my y is negative, hit enter again. It's going to be like guess, and then it's going to spit out as a value, right? So 3.77, I'm going to say, to the nearest hundredth. And there was another solution here, but it is clearly negative, so I don't want that if we want x seconds, right? So just the positive I want. Okay, so we didn't really show a lot of work here, but what we did, right, is we typed the equation into our grapher. We graphed it, and we adjusted the window. And then we use second, calc, 0 to find the point, right? And our left bound was a point to the left of the 0. Our right bound was a point to the right. And then it's going to be like guess, and you're going to hit enter. And then it'll spit out a value. So this would actually have worked for all the rest of these two. I'm going to have you show work for some of these problems because it is important to learn all 3 ways, especially when we go forward to tackle more challenging polynomial equations.